So, welcome back. We're now on to the fourth topic of Unit 1, which is all about bonding and structure. Now, we're going to give a brief introduction and recap the three different types of bonding, and then we're going to be focusing on ionic bonding. Now, this video should hopefully just be a recap of what you did at GCSE. So, if you don't already, by the end of this video, you should be able to explain ionic bonding in terms of the gain or loss of electrons, and you should be able to represent the formation of ions and ionic bonding using dot and cross diagrams. So hopefully you can remember what the three different types of chemical bonding are. You have ionic bonding, covalent, and metallic. Now at GCSE, you learned that an ionic bond is formed when a metal element bonds with a non-metal element. That covalent bonding is two non-metal elements joining together. And that metallic is obviously two metal elements joining together. Now this is mainly true. Later on in this topic, we'll go through how this is a slight simplification. But for now, you can carry on thinking along these lines. Okay, so in this topic, we're going to go through all three types of bonding. But for now, we're going to be focusing on ionic bonding. Don't worry if you don't get this reference. Some of you will. If you don't worry about it. Okay, so let's have a look at this reaction. Now you obviously have sodium reacting with chlorine to make sodium chloride. Now sodium is a metal, chlorine is a gas, therefore sodium chloride is an ionically bonded product. But let's have a closer look at what is actually going on. Let's break this into two half equations. So what is actually happening? Now the sodium atom is becoming what is known as a sodium ion. An ion is just a charged particle. Now the chlorine is becoming a chloride ion. So we have one positive ion, one negative ion. Okay, so how do you go from a neutral atom to a positive ion? Now you do this by losing an electron. Now a neutral chlorine, how does it become negative? This occurs by gaining an electron. Ionic bonding is all about the gain or loss of electrons. You have to form ions, and that happens by either gaining or losing electrons. So let's have a look at what's actually occurring. So let's start with the sodium atom. Now I'm going to draw this just like you did at GCSE. But when you are asked to draw dot and cross diagrams at the S level, you do it in exactly the same way. Okay, so even though we know it's slightly simplified, and that there are orbitals and subshells, etc., you are still just expected to draw it just as you did at GCSE. Now I'm only going to draw the outer shell with the outer electrons, because that's where chemical bonding really occurs. Now in some questions, it will say to ignore inner shells and only draw the outer shell. In some questions, it will ask you to draw all electrons. You just have to be very careful and read the question carefully. So as I said, I'm only going to draw the outer shell. Now sodium is in group 1, therefore it has one electron in its outer shell. I'm going to represent this with a cross. Now the point of bonding is that chemicals want to be at their lowest possible energy level. Having unpaired electrons in incomplete shells keeps the chemical at a higher energy level. To make these outer shells complete lowers the energy level. So there are two ways you could make the outer shell of sodium complete. Either you gain 7 electrons or it loses 1 electron. Now it is much easier to lose 1 electron. So the sodium ion is formed by losing this electron. Now this leaves us with a charged species. We've already said it's plus. Why is that the case? Well, the charge of an atom or an ion is determined by the ratio of electrons to protons. Protons each have a charge of +1, a relative charge, and each electron has a relative charge of -1. So how many protons does sodium have? Well, you should remember how to do this. Look at the periodic table. The atomic number for sodium is 11. So there are 11 protons, which provide a nuclear charge of +11, because each proton has a charge of +1. Now, as an atom, it will have the same number of electrons as it does protons. So each electron has a negative charge. So 11 electrons contributes -11 charge. So if we have +11, -11, we're obviously left with 0. The atom itself is neutral. There's no overall charge. Now, if we look at the ion, nothing has changed the number of protons. So it still has 11. These protons still contribute a charge of +11. However, we have lost one electron. Therefore, the electrons only contribute a charge of -10. So we take +11 minus 10. We are left with +1. The sodium ion has a charge of +1. So some people find this confusing. You're saying you lose an electron. Losing is surely negative. But you have to remember what the charge of the subatomic particle is. You are losing negativity. Okay, so think of yourself in a bad mood. If you lose that negativity, you become more positive. And that's what happens here. You start with your neutral atom. You lose negative charge. Therefore, the ion is positive. Okay, so let's do the same thing with the chlorine atom. Now again, I'm only drawing the outer shell. Chlorine is in group 7, so it has 7 electrons in its outer shell. Now with sodium, I used crosses. Therefore, with chlorine, I need to use dots, hence dot and cross diagram. One element should be crosses, one element should be dots. This makes it easier to see where the electrons have come from, where they've gone. Okay, so what happens to the chlorine ion? Now you think of the same sort of thing again. It wants to have a full outer shell. So it can either lose 7 electrons or it can gain 1. It takes much less energy just to gain 1 electron than to lose 7. So chlorine will gain an electron. But then it can't just gain an electron from nowhere. It has to come from a certain place. So I'm sure you can guess where it comes from. Yeah, I'm sure you guessed it. So the electron we lose from sodium will join the chlorine atom to form the chloride ion. Okay, so what is the charge of the chloride ion? Let's use the same technique. So chlorine has an atomic number of 17. That means it has 17 protons, each contributing a charge of +1. Therefore, overall, the protons contribute a charge of +17. In an atom, there's the same amount of electrons. Therefore, there are 17 electrons, each contributing a -1 charge. So overall, contributing -17. 17 minus 17 is obviously 0. An atom has no charge, it's neutral. Now, chloride ion has the same number of protons, but we have gained an electron. Therefore, the electrons contribute -18. Therefore, the charge on a chloride ion is -1. So we have formed our 2 ions. So what is the actual ionic bond? Well, the ionic bond is the attraction between the negative and positively charged ions. So if you are asked for a definition for ionic bonding, you would write this: ionic bond is the electrostatic attraction between a positive ion and a negative ion. So just to finish off, in this ionic substance, the formula would be NaCl, because you have a ratio of 1:1 between sodium ions and chloride ions. Let's just have a look at one more example. So let's have a look at magnesium chloride. So let's start with magnesium. Now, magnesium is in group 2, therefore it has 2 electrons on its outer shell, on its valence shell. So I'm just representing them again with crosses. So what happens? Now, the easiest way for the magnesium to have a full outer shell is for it to lose those 2 electrons. Now, because it loses 2 electrons, it's losing lots of negativity. Now, because it's losing 2 electrons, the magnesium ion has 2 more protons than electrons. It will have 12 protons, but only 10 electrons. Therefore, the charge on the ion is +2. So let's have a look at the chloride. Now, the chloride, as we saw before, needs to gain 1 electron. So we can gain 1 electron from the magnesium atom. So it's gained an electron, therefore it has 1 more electron than protons, 12 protons, 13 electrons. So overall, it has a -1 charge. So is this right? Is the formula for magnesium chloride just MgCl? No. Hopefully you can see the problems with this. This magnesium atom needs to lose 2 electrons to form the +2 ion. At the moment, it's only given away 1 electron to 1 chlorine. So what has to occur? Well, we have to have a second chlorine atom, so that the second electron can be lost from magnesium. Therefore, we form a second chloride ion. So now everything is balanced. You can see we have a ratio of 1 magnesium ion to 2 chloride ions. Therefore, the formula for magnesium chloride is MgCl2. So don't forget that some ionic compounds don't just have a 1:1 ratio. Most of them don't. So you need to think about how many electrons are either lost or gained, so that you can come up with the correct formula for ionic substances. So hopefully that was just a recap, and you've refamiliarized yourself with how to explain ionic bonding in terms of the gain or loss of electrons. And hopefully you can draw dot and cross diagrams to show the formation of ions and the subsequent ionic bonding. If you have any questions, make sure you write them down and ask me about them in class.